Chapter 5, Math 103. First, we start with some definition here. Event. Event is any collection or result of outcome or procedure. Single birth is an event. There are two types, simple event. Simple event is outcome or event that cannot be further broken. Like flip a coin. You either have head or tail. Rolling a dice, there are just 6 faces on each dice. Single birth. So these are all examples of simple events. And then you have a sample space. For a procedure consists of all the possible simple events. Sample space consists of all outcomes that cannot be broken into further. For instance, what is the sample space when you flip a coin? When you flip a coin, what's the possibilities? You have tail or head. So these are 2 possibilities. Or when you're rolling a dice, there are 6 possible outcomes. Those dice has 6 faces. So this is your sample space. Or when a baby is born, is either boy or girl. There are 3 different types of probability that each explain here. One they call the relative frequency. In this case, it has number of times events A occurred divided by number of times the trailer was repeated. And I show you example here that find the probability NBA basketball player make a free throw after being fouled. So based on the past experience, we come up with this result. So he already had 5,915 out of 6,679. So what's the chance of him make a free throw? Well, it's that. So this is relative frequency. Then we're talking about the classic approach. Classic approach, what is important in that is there are different sample events and each of them has equal chance of occurring. So when you roll a die to obtain number 2, each face of a die has the equal chance of happening. So what's the probability of getting number 2? 1 over 6. What's the probability of getting number 3? 1 over 6. What's the probability of getting number 5? 1 over 6. Again, because each face of a die has equal chance of occurring. Do not assume that outcome event is always equally likely. For example, we should not conclude that probability of passing a test is 50%. That's not true. So it's not equal chance of occurring. Actual probability depend on factors such as amount of preparation and difficulty of the test. So just in this case, or flipping a coin is either tail or head, and both have 50% chance. Or when you play blackjack, it's either red or black. So always 50% chance. Then the next one is subjective probability. Probability estimated using knowledge of relevant circumstances, like when trying to estimate probability of rain tomorrow. It just depends what part of climate you live. Whether you live in a rainy town or you live somewhere which is pretty dry. When trying to estimate probability of astronauts surviving a mission. A couple have 3 children. What's the probability of having exactly 2 boys? These are all the probability. See, they all have at least 2 boys in it, but which one? Exactly 2 boys. 1, 2, 3. See, there are 3 out of 8. So a couple have 3 children. The first 3, all 3 of them might be boys. The first 2 are boys and the girl. Boy, girl, boy. So these are all the possibilities. And 3 of them have at exactly 2 boys in it. So it's 3 out of 8. 8 is total outcome and 3 is what you're looking for. And these are some examples for relative frequency, classical and subjective that you could actually read yourself. Another formula that we discuss in probability is probability of A plus probability of A bar is equal 1. Example, there are 20 males and 40 females in one classroom. So altogether there are 60 students. When you randomly select one, what's the probability the person leave the room is the male? 20 out of 60. What is probability of female? 40 out of 60. So in a case like this, when you find the first one, in order to find the second one, you could always subtract from 1. So instead of doing the calculation for female, you could just say 1 minus 0.33 is 0.67. That's what it is, probably. This is in case there is always 2 possibilities, okay, male and female. They call it complements. Probability of A plus probability E bar is 1. So if you have 1 already, you could subtract from 1 to find the other one. So what is the probability of male? 1/3. How do you calculate probability of female? 2/3, because the sum is always 1. There are 5 red marbles and 10 yellows. So altogether there are 15 of them. There are 15 marbles. What's the probability of taking the red one? 5 out of 15. How do I calculate the other one? 10 out of 15. You could either do that or just subtract this from 1 to find the other one based on this formula. See, because 5 over 15 plus 10 over 15 is always 1. So if you have one of them and you want to find the second one, you need to take this and subtract from 1. Problem is always between 1 and 0. What's the probability of Thanksgiving be on Wednesday? 0. What's the probability of Thanksgiving be on Thursday? 100%. 100%, 0%. Probability cannot be negative. Probability is always positive. It doesn't go beyond 1 or less than 0 because it cannot be negative. So when you calculate the probability, make sure it's always between 1, 0, or 100% and 0%. And this is the examples. Now, on SAT test, there is one question with 5 choices. When you randomly select one, what's the probability of that one being correct? 4 out of 5. What's the probability of randomly or guessing 1 out of 5? 1 over 5. Probability of correct is 1 over 5. Incorrect is 4 over 5. There are 2 formulas. One, they call it addition rule, which we are going to deal with this a lot, and then complementary that we already discussed. So probability of A or B, probability of event A or event B is probability of event A plus probability of event B minus intersections. And we explain this on the later section. You could read this example after we discuss this. Okay, now we are talking about, let's say there are 2 sets of data. One set has these numbers. The second set B has these numbers. This is sign of intersection or and. A and B means, do they share any common? These 2 sets, do they have any number in common? Yes. They both share 7 and 10. They call these 2 joint events because they have some numbers in common. So if they both overlap, they call it joint events or union. Or we use this symbol. I'm sorry, this one is for the next one. So I shouldn't put that one here. Intersections. This is union, the second one. I should put this one here, union, okay? All right. Now let's look at these 2 sets, 3, 5, 7, 10, 4, 6, 8. Do they have any numbers in common? No. So what is intersection of A and B? None. They do not overlap. They are disjoint events. So you either have joint events that they overlap and they have some numbers in common, or you have disjoint events that they don't have any numbers in common. They do not overlap. They do not intersect. So in this case, intersect is 0. Now here, what is A intersection of B? Again, this is sign of intersection. A intersection of B means what number do they have in common? 7. Then you have A union B. In fact, I shouldn't cross this one here. What does A union B means? A union B means you bring all the numbers inclusive with no repetitions. Like if you already have 7 and 7, you just write one of them. So union means you collect all the numbers into one set. In one set, you have all the numbers with no repetition of the number. That's the union. Intersection, just the numbers that are in common. So two events are disjoint if they cannot occur at the same time. Like, determine if two events are disjoint. Arriving late for your stat class, arriving early for your stat class. They are disjoint. It cannot happen at the same time. Randomly selecting somebody who believes in UFOs, randomly selecting someone who believes in devil. Two different events, right? But it could happen together. So these two are joint. Somebody can believe in both. Event 1, event 2. Randomly selecting someone taking a stat test, randomly selecting someone who is female. It could be joint, right? It could happen together. They could overlap. Randomly selecting someone who is Democrat, randomly selecting someone who is Republican. Disjoint, they cannot overlap. Randomly selecting somebody treated with a certain medication, randomly selecting someone who received no medication. Disjoint event. Randomly selecting someone who plays hockey, randomly selecting someone taking a physics course. It could happen together, right? Somebody can take a physics course and play hockey. So joint event. And these are the same example. I just put the answers here for you. We also have another definition. They call it independent and dependent events. Independent, if occurrence of one does not affect the probability of occurrence of the other ones. Dependent is if the occurrence of one does affect probability of the second one. For instance, the first one, which is independent, they call it with replacement. Example. Determine if two events are dependent or independent. These are two events. When a month is randomly selected and ripped from a calendar and destroyed, it is July. Second event, when a different month is randomly selected and ripped from the calendar, it's November. Are these two joints? Yes, because when you take one out, okay, first of all, let's say on the calendar, original calendar, there are 12 months or 12 pages. When you randomly select one out of 12, this is a probability for the first, right? But now this calendar is missing one page. There are only 11 pages. So second time when you pull one out, the probability is 1/11. So what happened is this is dependent events. Means the second event depends on the first one. The first one impacts the second one. Okay? They call it without replacement. We did not replace it. We took a page and there's one page missing. So independent is with replacement, dependent is without replacement. Another example, when a baby is born is a girl, what's the chance of a baby is born as a girl? 1/2. When a single die is rolled, the outcome is 3. 1/6. These two are not depend on each other. They have nothing to do with each other. So in that case, the probability multiply 1/2 times 1/6. These are two independent, and these are dependent. There are two questions on the test. One is the false and true, and the second one is multiple choice. With 5 answers. What's the probability of the first one is correct and second one also is correct? So in multiple choice, when it's false and true, when you select one out of 2, what's the probability of that one is correct? 50%. Now, when there are 5, second question, there are multiple choice. There are 5 of them. What's the probability of randomly selecting one is correct? 1/5. So you multiply. So these two are independent. Whether you pick the right one or the false one, it has no effect on the second one. These two are independent. If two events are independent, then intersection is this. That means the probability of the second one, if A and B are dependent, then it's probability A times probability of B. I think these are vice versa. It means this should be like that. Because that means this P/A means the second event would change because of the first one. This is an example. 8 girls and 5 boys are in one class. If we randomly select 2 people, what's the probability of both of them are girls? There are altogether 13 of them. When you select one, what's the probability of that one being a girl? 8 out of 13. With replacement is you randomly select 1 out of 13, and then you ask the person to return to the class. So nothing changed. The numbers has not changed. You still have 8 people, 8 girls in the class. So when you call for the second time, still is 8/13. This is with replacement or independent. Independent is when you replace it and nothing changed. Let's say there is a class of 10 people and I ask one person to leave the room. That would, the chance of that being male, let's say, is 1 out of 10, right? And then I ask the person return to the class, and then I call for the second one. Nothing changes, still is 1 out of 10. Without replacement is impact. Let's say there are 13 students in the class and 8 of them are girls. So when you call somebody outside, what's the probability that one be a girl? 8 out of 13. If the girl stays outside of the class and she does not return, then there are 12 people in the class and 7 girls. So for the second time, when somebody or a student leave the room, what's the probability of that person being a girl? 7 out of 12. So this is without replacement or dependent. And these are all the homework problems that you have here. So I think the first one is very simple. There are, you could go ahead and read this, and if you have any question, you could ask me. Some of them are really simple. And the solution is here. Like here, you have this. So if the subscriber is selected at random, what's the estimated probability? 3 or fewer movies. 3 or fewer movie. So that means you start from here, you go back. Okay? What's the problem? This one means this. What is the probability of X is less and equal to 3, which is probability of X equal 3 plus probability of X equal 2, probability of X equal 1, plus probability of X equals 0, which is here. At most 3 movie means probability of same thing, X, it doesn't go beyond 3. It's the same thing. 4 or more, probability of X is 4 or more. So it's probability of X equal 4 plus probability of X equal 5. See, you pick the numbers from here, 4 and 5. 0 or 1 more, what's the probability of X equals 0? See, probability of X equals 0 plus probability of X equal 1. More than 1 movie, probability of what? X is greater than 2, not, it doesn't say equal, so it is what? Probability of X equal, which one are them? More than 1 movie, so it's probability of this 1 movie, I'm sorry, X greater than 1, so it's probability of X equal 2 plus probability of X equal 3 x equal 4 and 5. See, it said more than 1. It doesn't say 1. Okay, so more than 1 is means start from 2. Some of these are, you could actually read it. It's very simple. This part is talking about the complement here. You have the solution. See, there are 8,000 passengers and 1,700 of them final destination in Phoenix. So what's the probability of selected passenger in Phoenix? 1,700 over 1,000. I put everything here for you to read. So in this problem, they are saying if a professor assigned 5 problems to be completed at the next class, 2 of the 5 problems will be selected at random and collected. So let's say I'd have here, I'd have A, B, C, D, E. You just pick A, B, and C. So in that case, these are all the possibilities. If you take 2 out of 5 numbers, see there are 5 problems, A, B, C, D, E, okay? First, they show you all the possibilities. If you take 2 out of 5, each time you take 2 out of 5, these are all the possibilities. But if you if you answer only 3 questions, means you don't have D and E. So all of them that has D and E must not be counted because you just answered 3 out of 5. You just answer A, B, and C. So when the professor select 2 out of this, chance of you have a correct answer is this, 3 out of 10. And the second part is what if you answer 4 questions? 4 out of 10, but how many of them has A, B, C, D? This doesn't, because you didn't answer E. See, it was A, B, C, D, E, but you didn't answer. You just answered the first 4 correctly. So anything that has E should not count, because your correct answer was A, B, C, D. All the possible A, B, C, D is okay. So it's 1, 2, 3, 4, 5, 6, 6 out of 10. This is very similar. I'm sure you could read that yourself. I'm hoping the solution is make you understand all this. This is talking about that exclusive, joint, and disjoint. And these are the problems that you have some problems here that, like in this one, they're saying that based on the past sales, the manufacturer report that the customers buying both a washer and dryer, 42% purchase extended warranty for the washer. For the washer, 42%. So this is given. I place a check mark next to it. 51% purchase a warranty of the dryer. So the dryer is 51%. So if you take 51% and multiply by 100, that's what you get. So 51, 510, these 2 given, and the total is 1,000. So 3 numbers are given here. They ask us to fill the rest. So you need to find all this. Now, what we're trying to do here is, first, we are using this formula. What is the probability of washer or dryer? Remember the formula we had in the past for the or? Let's see if I can find that formula. But we use this formula often here. This formula is probability of A or B is probability of A plus probability of B minus probability of A and B. Probability of the union, and this is intersections. They call it addition rule, okay? So let's say here, we want to find probability of washer or dryer. This one is given. Here it said 63% purchase at least one of the two, either this or that. So that given, 63. Probability of people who bought washer, right here. Probability of people who bought dryer is given. So in this one, the only one that is unknown is intersection of washer and dryer, which is intersection of washer and dryer is number that you need to put here. See, you overlap washer and dryer. So you find that to be 300 or 0.3. You put that number here. Now, as soon as you find this 300, then the rest you could find. So far, look, so far we have this, we have that, we have this, and that. Then you should be able to find the rest. For instance, 420 plus what number is 1,000? You could subtract. 300 plus which number is 420? 120. 300 plus which number is 510? That gives you 210. So you should be able to find 1, 2, 3, 4, 5 other numbers as long as you have this 4. Like what is intersection of washer and dryer? See, washer and dryer, 300 out of 1,000. These are all very similar. See, these numbers are given. These 3 are given. Probability of A is 20, which is I show you 0.2 times 1,000 is 200. That's where 200 come from. Probability of B is 150. This is what. So you have these 3 numbers. So what you need to do is find this one, which is intersection of B and A, intersection of B and A, intersection of gas and GPS. And I calculated that here. You need to find this one. Probability of A or B probability of A intersection of B is probability of A times probability of B. Okay, so A intersection of B, which is this numbers, is 0.2 times 0.15. Remember, GPS and the gas, they are independent events. They have nothing to do with each other. And 2 events are independent if 2 events are independent, then probability of intersection is probability of A times probability of B. Because one is the gas, the other one is GPS. These 2 have nothing to do with each other. So when we ask you to find intersection, when we ask you to find intersection is probability of A times probability of B. Both are given in the problems here. When you find these numbers, then you should be able to find the rest. The rest of the problems are all very similar. This type of problem, what you need to do is you need to add all these numbers on each row and each column. When you do that, numbers should match here. When you add these two in the column and all these, they should match. So this is a table that you need to work on to answer those questions. So the first thing to do on this problem is adding all those. And this is very similar to the other problem that we just did.